Okay, so let's find the derivatives of each of these functions here. So starting with a, we see here that we have this quotient, and we could use quotient rule, but if you ask me, it's much easier to rewrite this as 2x plus 3 to the negative 3. And what that allows me to now do is that if I'm looking for the derivative of this, right, so I'm looking for the derivative of the original, and of course it's equal, the derivative of the whole thing, obviously. Anyways, the derivative of this function now, you could think of this whole thing as u, right? This in the green is u, okay? And you can use chain rule, okay? So it's the derivative of u to the negative third times the derivative of u. So let's write down what chain rule says up here. Let's see if we have space. So chain rule, right? It says that the derivative of f of g of x is the derivative of f with g plugged in, and g isn't changing. Don't think to plug in the derivative of g. Okay, you take the derivative of f and you plug in g times the derivative of g. Okay, so in this case, right, this 2x plus 3 takes the role of g. And then you think, well, what's the derivative of the outer function? Well, you bring down the negative 3, 2x plus 3. Again, you just plug in g. This is like u, right? And then minus 1 up here times the derivative of this inside is just 2. And you get negative 6, 2x plus 3 to the negative 4. And I don't care, you could leave it like this. This is your answer. Okay, similarly with this one, you want to run through a similar technique, right? The derivative is just the same thing as x to the third plus e to the x to the 1/2. And it's much easier to see that now this is like your u, and you take the derivative of the outer function, the 1/2 comes down, g stays the same on the inside to the negative 1/2 because I minus 1, and then times the derivative of the inside. The derivative of the inside is going to be 3x squared, the derivative of x to the third, plus the derivative of e to the x is just e to the x. And again, you can leave it like this. This is full credit. Okay, now here, this is a good one because here you got to use two rules. So we're looking for the derivative, and we have to see that it's going to be the derivative with this being u. That's the plugged in function, right? That's g of x, right? And then this is f of g of x. So what is it? It's f prime of g of x times g prime, right? Now we know what f is and what g is, so it shouldn't be a problem. But we need to remember, what's the derivative of log u? 1 over u, right? So now it's log g of x, so it's 1 over g of x. In this case, g of x is sine x times cosine x, times the derivative of g of x, which is the derivative of sine x times cosine x. So we got to write that as derivative. I'm going to try and put a little derivative tick there. And then now I need to sit here and spend some energy on finding the derivative of cosine x sine x. And you want to just pull it to the side if you want, and just figure this out. Here you need to use product rule. So product rule says that the derivative, f times g, the derivative is f prime times g plus g prime times f. And that's product rule. So here, what's the derivative? Well, what takes the role of f? Sine x. What takes the role of g? Cosine x. So the derivative of f is cosine. So it's going to be cosine. Yeah, running out of space here. So it's going to be, let's write this, 1 over sine x cosine x times, and then now let's start writing it. So the derivative of sine x is cosine x times cosine x plus the derivative of cosine x is negative sine x times sine x. So be sure to use the product rule correctly there. That's what I just did. I could simplify it maybe a little bit, make it look a little bit cleaner as cosine squared x minus sine squared x over sine x cosine x. And just leave it like that, that's fine. Okay, now it's getting to be just a headache, and we have to sit here and we just got to be careful, but again, it's just going to be that we rewrite it, right? So again, we're looking for the derivative of this whole thing. So we rewrite it as 1 plus x plus e to the x over 2, and then this is 1/2, and then the outer part is 1/3. Okay, so you got to convince yourself that these two functions are the same. Right, now let me make sure that I actually did this correctly, and I think I did. Yeah, this is e to the x to the 1/2, which just becomes e to the x over 2. And now I differentiate this. So it's just a headache and a lot of bookkeeping. So let's try and be as organized as I can. This whole thing takes the role of u. The derivative of that is going to be 1/3, 1 plus x plus e to the x over 2 to the 1/2, right, to the negative 2/3 times the derivative of this inner thing here. And again, we got to be really careful with how we do this. Let me see. Did I mess up with parentheses? What was the inside? This is the inside. Right. Okay, so the derivative of this is going to be the derivative of 1 plus the derivative of this. So let's make sure that I did that right in my mind. So the derivative of 1 is 0. Now I need to find the derivative of this here. And again, you need to use chain rule. And I'm going to pull it off to the side, use as much space you have somewhere else, wherever. Sit here. Okay, so now I'm off into the side, and I'm just trying to find the derivative of x, e to the x over 2 to the 1/2. Okay, and I got to multiply that over here. So what's the derivative of this? It's going to be 1/2. It's going to be 1/2. The 1/2 comes down. X plus e to the x over 2 to the negative 1/2 times the derivative of this, which is 1 plus, now this e to the x to the 1/2, we need to use chain rule again. You need to think of it as e to the u. The derivative of e to the u is e to the u times u prime, right? The derivative of e to the u is e to the u times u prime. So here, it's just e to the x over 2 times the derivative of x over 2. But we should see that x over 2 is equal to 1/2 x, and the derivative of that is just 1/2. So there's just a 1/2 in front here. And now I have what goes right here, which is 1/2 x plus e to the x over 2 to the negative 1/2 times, and I'm going to try and erase this. There we go. Times 1 plus 1/2 e to the x over 2. And that should be correct. That's the whole thing, I believe. And we could check it. We could go over it together and see if you guys get something different. But yeah, that's definitely a headache of a one. This next one we have here, it says ax e, now that I've written over everything, negative b to the x, right? I'm going to forget about this a for the time being. I'm going to multiply by a at the end. A and b are constants, so you can pull out a because it's a multiplication of a constant. The b in the exponent, though, that's a little bit more tricky. The first thing you need to do in doing this, once you realize that you can sort of, just know that it's a times the derivative of x e to the negative bx, right? Because you could always pull out your constant, is that you need to know how to differentiate this, right? And differentiating that, you've got to first see it as a product. And it's tricky when you're doing chain rule and all these things. The only way to do it is with practice. You got to sit here and practice these problems over and over and over again. So it's a product. It's x times e to the negative bx. So what does product rule say? Product rule says this, right? Don't forget up here. Product rule is that, right? So what takes the role of f? This takes the role of f, and then this whole thing takes the role of g, the e to the negative bx. So by product rule, this is going to be a times the derivative of f is 1 times g is e to the bx plus the derivative of g is going to be tricky. We got to take our time. So now you got to pull it apart and you got to say, okay, well, what's the derivative of e? What's the derivative of e to the negative bx, right? What's the derivative of this? Okay, and to compute this, right, this whole thing functions as u. The derivative of e to the u is e to the u times u prime. So in this case, it's e to the negative b times the derivative of negative b times x, which is just negative b. So that written a little bit neater is negative b e to the negative bx. And then now I have g prime. So it's just minus, I'm going to erase this here, and I'm going to put minus b e to the negative bx times f, right? Times f is just x. And now I'm done. I put it in parentheses and I'm done. This is my answer for that one. Now the last one. So now we have, right, this e to the negative x squared. You should see this like u. The derivative is going to be e to the negative x squared times the derivative of this, right? The derivative of negative x squared. And that's going to be e to the negative x squared, and it's times negative 2x, because that's the derivative of that. And this will be fine. Negative 2, you can make it a little bit nicer. E to the negative x squared. Okay, and then that's that for those ones. Now let's go on to the other ones. We have more here. So sine inverse of x squared, right? We can remember our rule for the inverse function, right? We should know that the derivative of the inverse function is equal to 1 over the derivative of the forward function with the inverse plugged in. Okay? And that's going to help us with this because you first got to see this x squared like u. Okay? And then you say, okay, well, what's the derivative of sine inverse of u? Well, using this here, right, it's going to be equal to 1 over, right, the derivative of sine, right, because that's the forward function, which is cosine, and then f inverse is sine inverse, and then of x squared times the derivative of x squared is 2x, because x squared took the role of u. Now this here, right, this here we can simplify. We could derive the rule for the derivative of sine x. What is the derivative of sine x? And just skip this whole inverse rule, because that's what it's based on, this rule. But I always forget what that is. And I'd have to, you could just do it like this, but you could just know what this one is and then plug in. So I think it's like, what is it? I'd have to draw the triangle out, and I'd have to say that, so what is it in this case? So it's going to be that sine inverse x squared is equal to y. So that means sine of y is x squared. So it's x squared over 1. And then this is going to be x to the 4th. 1 minus x to the 4th? 1 minus x to the 4th. Square root? Is it square root? Yeah, this is like the square root, right? Yeah, it's x squared squared, which is x to the 4th, plus the missing side squared is equal to 1 squared. So it's 1 minus x to the 4th, and then the missing side squared is square root. So then what is it? Cosine of y is going to be the square root of 1 minus x to the 4th. Okay? Sit here and take your time with that. But I generalize the rule. The general derivative is 1 minus x squared, the square root over it. And then you could just use chain rule a lot easier for this. So what do I mean by this? I'll do this one again, if I can just somehow find space here. So with this fact, right, it makes it a lot easier, because what you can say is you could just sort of say that, like, this is u, right? This is u squared, times the derivative of u, right? Now that's chain rule. And then you can just do that here, because now you have, well, what is this? This is sine inverse of x squared, the derivative, right? Well, what takes the role of u here? This x squared. So it's going to be 1 over 1 minus u squared. U is x squared, so this becomes x to the fourth, all in the square root, times the derivative of u, which is just 2x. And then you have it again. Okay, with this rule, it's much easier. You can do it a little bit faster, but you could derive this rule using that one. So you could derive this rule, right, this one, from the one above. And we could derive the one above as well if need be. But okay, now let's do this real quick. So this is saying, right, this is the same thing. Don't get mistaken that this is saying this, right? So the inner function here is sine x. So the derivative is going to be 3 sine x, the whole thing squared, so sine squared x, times the derivative of sine, which is just cosine x, and then you're done. Okay, that's just a basic application of chain rule. Now here, this is a key one. To do something like this, what we really need to know is that the tangent line to any graph is the derivative, is the slope. Let's write the slope, sorry. The slope of tangent line is the slope of, oh my god, what am I writing? I don't want to redo this whole video. I lost my train of thought completely. The slope of tangent line is the derivative of function. Okay, so we need to know this fact. This is the key fact, okay? Okay, the slope of the tangent line is the derivative of the function at that point, And we're going to use a specific point. So we want the slope of the tangent line to the curve y equals blah, 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 blah at this point. So I have a point on my line. I just need slope. So I find y prime. Y prime is using chain rule, right? This is 3x minus 1 squared, and then plus 2, the derivative of 2 is 0. The derivative constant is 0. That's y prime. And remember, this gives the slope of the tangent line at any point x. The x point that we care about is 3. So m is equal to 3 times, instead of writing x, I put 3 minus 1 squared. I'm going to get 3, 2 squared, 4, 12. M equals 12. And now that I have m equal to 12, I know the slope of my tangent line. Okay, because I plugged in x into that derivative, and I got the slope of that tangent line. Now once I have that, y minus y1 is equal to mx minus x1. That's one way you could write the equation of a line. You could do y equals mx plus b, it doesn't matter. But you have y minus y1 is 10, that's the point. 12, x minus x1 is 3. And you get, this is one equation, that's the way you write it in point slope form. And the other way, slope intercept form. You know m is 12. X is 3. B you don't know yet. When x is 3, y is 10. So you're going to get 12, 24, 36 plus b, 10 minus 26 for b. And then you could write it again. You say y equals 12x minus 26. And this is the same thing. These two lines would be the same. If you were to sit here and distribute, you get negative 36 plus it, you get minus 36 exactly. So these two would be the same if you solve this for y. If you added 10 and distributed, you get the same thing in both cases.